Hello guys, welcome to the physics lesson number 18. This is the 2026 physics lesson in number 18 on moments, part number 2. Okay, remember in the first part we did the theory part of moments and then showed you examples of how questions come in moments or on moments, and then today we are also continuing to bring more and more questions on moments so that at least you become comfortable to solve questions on moments. All right, so without further ado, let's go straight into the questions and the lessons. So this was question 3 in a certain paper. The question was like A, figure 3.1 shows a uniform meter rule of mass 120 grams suspended at midpoint from a spring balance which is calibrated in Newton. All right, what they're telling us, as I was saying, is reading and understanding patiently. So you read to say, this figure here, this one here, shows a uniform meter rule. So you have a uniform, meaning same size. The word uniform means same size meter rule. So whenever you hear meter rule, when they say meter rule, it's that meter rule which is actually equal to 1 meter in length or also equal to 100 centimeters in length. That is the main thing. When you hear meter rule, oh, we are talking of that meter rule, which is 1 meter long, okay, 1 meter long, 1 meter long, or 100 centimeters long. That is the length. Then they're saying of mass 120 grams suspended at its midpoint. Okay, let me read again. So figure 3.1 shows a uniform meter rule of mass 120. Okay, so this same meter rule has this mass of 120. Okay, that's its mass. This meter rule here, its mass is 120, suspended at its midpoint from a spring balance. So there is a spring balance here on the midpoint. So the moment again you hear the word midpoint, if at all you come across it in a word, it means at the center. You are dealing with a 1 meter rule which is 100, then it means at the center, the other side going this way, if it is at the middle here, this part is at the middle, meaning the other side, it is 50 centimeters or 0.5 meters. Then this other side coming this way again, it is also 50 meters or 0.5 meters. That's what should be in your mind. That's why they are mentioning those. Those are not being mentioned for decoration. They are mentioning them to now begin giving you the hints of what is going on. So suspended at its midpoint from a spring balance. So this is a spring balance here, which is calibrated in Newton. So this spring balance is in Newton, meaning a spring balance. What does a spring balance do? A spring balance measures force, which is in this case even weight. So this guy measures force. In this case, it will measure the weight. Now that it is balanced at the middle, if this thing is balanced at the middle, meaning that this spring balance is able to measure the weight. So if it is balanced, okay, it means that what is on the right side going this way is also equal to what is on the left side. Okay, so meaning that if it is balanced, it means the principle of moment is applying here. The clockwise moment is equal to the anti-clockwise moment. Okay, so that is another concept to remember. All these which are being mentioned, they are leading you to that to begin understanding what is going on. So now let's analyze what is happening now. So when we come to the figure, we have a stone here. Okay, a stone here. We don't know what the mass of this stone is. It is placed at what? At as 0, then it is at 20 centimeters from the beginning of the ruler here. Then we go there, or we have 50 centimeters, meaning from the start to where the spring is, it is 50 centimeters. Then now we have 100-gram object here placed at 60 meters, meaning this 60 centimeters, I mean, it is from the 0, 20, then we have 50 here, then we have 60 here, then we go there 100, right? So that's what we see. Now listen to the question. They're saying a stone suspended at 20 centimeters mark, as we have seen, is balanced by 100-gram mass suspended on the 60 centimeter mark. Assume g acceleration due to gravity is equal to 10 meters per second square. Then they're saying A, calculate the mass of the stone. So we calculate the mass of the stone. So in moments, they're asking you to calculate the mass. Yes, you use the principle of moment. So now we calculate the mass here. So if these things are balanced, it means that the moment on the left, which we can say moment 1, is equal to moment on the right, which is moment 2. So meaning moment 1 and moment 2 are equal. Moment 1 is equal to moment 2. Okay? Then, there now, it will mean that how we shall solve now is this. We know that moment 1 is going to be found. Moment 1 is going to be equal to mass 1, because here if they're saying calculate the mass of the stone, and then the other object is also in grams as mass, meaning we can also change the way we deal with moment. We can say moment 1 is equal to mass 1 times distance 1. So that distance moved by mass 1. Then we'll say moment 2 is equal to mass 2 on the other side times distance 2. So now using the principle of moment, these two guys are equal. So you say the principle of moment we use is m1 d1 is equal to m2 then d2. Okay, so now it is your duty now to begin identifying what is m1, what is d1, what is m2, what is d2. So when we come, this one will become, let me clear this. So this one will become m2. Then its distance from here to where it is hanging from, this one becomes the pivot. This distance is from here, altogether from here to here, it's 50. All right, it is 50. Now we just want to know from here to here what is the distance. So if we want, we can say 60. No, that is it is not going to work. So what we want to know is this distance from the pivot. Remember, always from the pivot to where the object is. This distance it2 is the one we want. So if from here to there it is 50, right? Then we will say we already know that. Let me clear this part, but bear in mind what is there. I want you to work with a clean thing. So if from here to here it's 50, Then from here to here is 60 there. All right. Then what about just from here to here is what? How can we know that? We can just say 60 minus 50, it is 10. So we will know that here it is 10 centimeters. You see, it is just thinking. Okay, if you are lacking thinking in science, you find science very, very difficult. Very, like this thinking that I've used here, I am teaching it to you, but you can also know it if I guide you logically to think. All right, so meaning that even yourself, in your own logical thinking, you should be able to guide yourself to know. So you're saying from here to there is 50, then from here to there it is 60. Then what about from here to there? Just a 60 minus 50, you get the 10. So we know now that, all right, so this is D2, meaning the D2 now is equal to 10 centimeters. Then we also want to know D1. All right, so now we are saying this. Okay, let me wrap now that we have already dealt with this. Then this guy also will be mass 1. So mass 1 is unknown, but let's find its distance from the pivot here. What will be its distance here? So again, from the object to the pivot. So the distance here again will say if, again, so they've given numbers. In physics, they never spoon feed these guys. That's the problem. They'll just give you a number to begin working on your own. So you see from here to there it's 50. Then from here to here it's just 20. From here to here it's 20. So if we remove 50 minus 20, what do we remain with? 30. So from here to here is 30. So that if we say this 30 plus this 20 going this way, total them, they'll give us 50. So this side it is 30 centimeters. So all this work that you are doing, you see this question is 2 marks, but all this work that you are doing to understand everything is just leading you to get 2 marks. So when people fail in science, don't think that teachers are not teaching or what. No, it is how stingy they are in the way they distribute marks. Imagine you do all this work of identifying what information you need to come up with, and after you identify that information, you solve again. Again, they just give you 2 marks. You waste a lot of time on doing that, and then you get few marks and you end up not finishing the paper. So now we will substitute. So M, this one M1, we'll just put M1 is unknown, times D1 is 30. So put 30 centimeters equals, don't worry about units. Then M2 is 100 grams. So you put 100 grams times, then D2 is 10 centimeters. So it will be 10 centimeters. Then you multiply to say M1 times 30 centimeters. It will give you like 30 centimeters. Then M1 then equals, then you say 100 grams times 10 centimeters. It will be 1000. Then you say grams, then centimeters. Now remember, all you want to find here is the M1. That's what you're looking for. So you divide this side over 30 centimeters equally this side 30 centimeters, so that this goes, you remain with M1 equals, so this centimeter and this centimeter goes. That's why I told you don't worry about units, because in questions like moments, units sort themselves out. So say 1000 divided by 30, we will be getting like 33.333, but to get the answer to 1 decimal point, so say 33.3, then there's gram here, so that will be the mass. So say therefore mass of the stone is, if you want, just end at 33, but since this figure has like 3 significant figures because it is a measured value, so you put 0.3 grams there. That's how you handle. Then we come to the question B. They're saying, why does the mass of the meter rule play no part in the calculation in 10 or in A? Like they're saying, we did not use this mass they mentioned here. You have seen there's this mass of the ruler they mentioned. So why does it play a role? Because it is balanced by the 2 masses. So you can say because it is balanced by the 2 masses, so that you don't waste your time. Because it is balanced by the 2 masses. Because if this thing is balanced as the question stated, it means the upward force pulling up is equal to the downward force, and then the downward force are the mass of the stone and then the mass of this other thing. They're the one pushing down, so they're balanced. All right, so let me clear everything so that we have a clear thing here. All right, then we come to what is the reading on the spring. All right, so what is the reading on the spring? So we come back to the reading of the spring. Okay, so now the spring is going to read the 2 masses. You know, it will read 120, because this thing is all right, so these 2 things are pulling down, so there is this mass going down, all right, then also this mass going down. So these are the left masses, or downwards. Then there is another one which is upward. So the upward is the one that it is going to cause to read. So the downward forces are the one that are going to make the reading here, because they're pushing this thing down and they are causing the spring to go down. So you add like 3300 plus 33.3, which will be equal to 133.3 grams. Now this one you convert it into mass, because the question is asking us to find the reading on the spring balance, and the reading is in Newton as they mentioned. So I've said the mass of the 2 that are pushing downward, it will be 133.3 grams. Now this change it to kg by dividing by 1000. So you divide by 1000 to convert grams into kgs, so that you say we're We're saying plus 100, that is the answer there, then divided by 1000, so that we get like 0.13. all right, so 0.13. So this is kg. Now the reading will be equal to weight. So reading will be equal to the weight of those two objects, of the two objects. So now, how is it going to be found as weight? Note this we have found. Weight has a formula which is weight is equal to mass times acceleration due to gravity. And this now is the mass should be in kg, which is 0.13, okay, kg, times now g is acceleration due to gravity, the one they provided us with here. This one, g, is that one. So we will now get that one. We will use the units as 10 Newton per kg as another unit for acceleration due to gravity. So you multiply like 0.13 times 10, it will be 1.3. Then kg and kg cancel, you remain with the Newton. So that will be the weight. If not mistaken, that is the answer there. All right, so you move. Let's move to the next question. Here is another question on moments. So this question was like, a meter rule is suspended on a knife edge placed at the 40 centimeter mark. So there is a meter rule. This one is a meter rule. As I told you, meter rule when mentioned, just know that you are dealing with the length of 1 meter or 100 centimeters. So in this case, the Viv input is 0, 15, 40, 100. So from 0 to up to the end, it is 100, which is the correct length of 1 meter. So they're saying a meter rule is supported on a knife edge. So there is a knife edge here where it is supported here, okay, at the 40 centimeter mark. So at the 40 centimeter mark there, they're saying it is found that the meter rule balances when a mass of 45 grams is suspended from the 15 centimeter mark as shown in figure 2.1. So they're saying this meter rule balances when a mass of 45 grams is placed or is suspended from 15 centimeter mark. So meaning that if logically, before we even go, the center of where if this object is not placed here, and then the knife is just supported by, the meter rule is just supported by a knife placed at 40, will this thing balance? No, let's learn guys to think it will not balance, because this side it is longer, this side is more longer. If going this side to here is 40, then this side is 60. So this thing will not balance, it will fall on this side. Now to make it balance as the situation is now, there was this mass which was placed here, meaning that it was able to balance now because of this mass which was placed here, the 45 gram. So meaning that for it to balance, meaning this at the center where the 40, let me get this one, at the center where the pivot should have been, somewhere here, the center which could be here, meaning from the center to this side 50, and also from the center coming up to the end here should be 50. Now that's where it was supposed to be balanced. Now if it wasn't, it is balanced on where it is now. It means that what is causing it to balance, there is a mass here at the center, which is the weight acting now downwards. That one is acting downward, not like this. Let me try if I can remove the arrow. Yeah, I can't remove. Oh, cool. Let's see. Oh yeah, so the arrow is out, so we can point it down properly like this. That's how the weight is pointing. So now this is the weight which is now balancing. So now we will remove this part, yeah, and this part. So there's weight at the center which is balancing with this mass here. That's why this thing cannot move to the other side, because they're saying it is found that the meter rule balances. So the moment you hear balances, principle of moments comes in. So this weight and this, they are balancing each other. All right, and then you need to know what is the distance from here to where the weight is acting from, and then also the distance from the same pivot where this object is to the pivot. Those distances must be known. So let's read the question before we come back to that. They're saying if the center of mass of the meter rule is at 52.5 centimeter mark, calculate the mass of the meter rule. So they're saying the mass of the meter rule, we calculate the mass. So meaning here, instead of putting weight, we shall change to mass. All right, now meaning that we shall call that for us to be able to calculate the mass, since it is balanced, we shall now summon or apply the moment, the principle of moments, where now if we are using masses, we'll say we'll use mass 1 times distance 1 is equal to mass 2 times distance 2. So this guy will be mass 2, its distance here will be distance 2. Then this mass of the ruler, it will be mass 1, its distance from the pivot, it will be d2, or it will be mass 2, its distance, so what have I done? Okay, I've called that, so this one will be 1 1. All right, so this one will be d1, then this mass here will be mass 1. All right, so now we need to know what will be the distance from the pivot to here. It's easy, it's just to know from here it's 40, from there, from here it's 15, from there it's 40. So what about from here to here? It's just say 40 minus 15, which is going to give us what? 25, right? Right. So here it will be 25. So say, okay, the space is not enough there to write, so say d2 is 25. All right, centimeters. Then what about d1? d1, they've told us that the center is at 52 centimeters, meaning at the center here, from here to there, the distance is 52.5 centimeters. So then we need to know then how much from here to there. It is simple. From here to here, it is 40. Then from here to there, it's 52.5. Then we'll remove the 40 from 52.5 to know here. So just say, okay, 52.5 minus 40. What is our answer? 12.5. So say, okay, now our D2, our D1 is 12.5 centimeters, right? Right. So now let us now substitute. So our mass 2 is 45. So just say, okay, mass 2 is 45. So mass 1 is an unknown, or say just mass 1 times D1, which is 12.5 centimeters equals M2. M2 is 45, you see, 45 grams times D2 is 25 centimeters. Then we'll multiply M1 times 12.5 centimeters. What are we getting? We are getting 12.5 centimeters M1 equals, then we'll multiply 45 times 25. So 45 times 25, we are getting 11.25. So it will be 11.25. Then there will be grams, then centimeters. Then here we are looking for M1. So to get rid of the rest, we'll say divided by 12.5 centimeters. Even here, 12.5 centimeters. So this one and that one goes. So what are we remaining with, ladies and gentlemen? We are remaining with M1 is equal to, so say this one which we have divided by 12.5. So divided by 12.5, we are getting 90. So this one and this one cancels. So remain with 90. And then G there, grams. So that is M1. That's the mass of the ruler. So say, therefore, mass of the ruler is 90 grams. Like that. Okay? So far, that's how we are supposed to analyze. Then, a different question. So all that work we have done, here it was 5 marks. I don't know, but this solving is 2 marks. This is for other questions which were mixed with moments. Then we come to this other question which came in another year, which says figure 11.1. Figure 11.1 shows a uniform meter rule balanced horizontally on a knife edge placed at the 58 centimeter mark when a mass of 20 grams is suspended from the end. All right, so we have again almost the same language. We are told we have a uniform meter rule, 100 centimeters should come in mind, or 1 meter, balanced horizontally, meaning when it is balanced, principle of moments must come in your mind. So balanced on horizontally on a knife edge placed at 50 centimeter mark. So this is a knife edge, 50 centimeter mark as shown here, when a mass of 20 grams, this mass of 20 grams suspended from the end there. So we see what is going on there. Then we come to the question which says find the mass of the row. So they need to find the mass of the row. So the same thing, if it is not balanced at the center, it means that there is already the mass, the rule, it means that already there is an issue to do with the rule working. So let me do this. Let me just see if this will draw. Okay, I want to get this situation on this side. The same situation, I want to duplicate it here so we see. If this is the center, at the center it should be like this. If it is a meter rule, at the center, this side should be 50, the other side 50. Like, what am I saying? From here to there, 50 centimeters. From there to there, 50 centimeters. But now what they have told us is that no, they pushed it which way? They pushed it this way. If it is here, at the center, then on top here we should say 50 centimeters, 50 centimeters exactly at the center. Now if it is not like that, they're saying 58, meaning they pushed it this way. Okay, meaning that leaving now, okay, so that's what they did. So they pushed it this way, meaning from this side to this side it's actually now 58. It's quite longer. So meaning the center has been left at 50. So the center has remained at 50. That's where the mass is. That's where the mass is. So here it is at 50. That's where the mass is. Then here we are at 58, as seen in the diagram. Then meaning that if they've put an object here, that one of 20 grams, meaning we need to know if from here to there it is 100, then from there to there it is 58, then we'll just say okay, 100 minus 58, 42. So we'll say okay, it means from here it's just 42 centimeters. Then we will also need to know from where the mass is and the pivot is. We'll say if from here to here it's 50, then from there to there it's 58. What about from this to this? So 58 minus 50, which is just 8. So that distance is 8, just 8. So meaning that on this side we have M2, this guy M2. Alright, M2, good, M2. Then we have D2, which is 8 centimeters as we have seen. Then this side, this mass becomes M1. Then this its distance becomes D1. So say D1 is equal to 42 centimeters. So the question, many questions, they are coming the same, as you can see. they're like coming the same, but let's see where we are going. So if they say find the mass of the ruler, so now we'll use this one. So say, okay, M2 D2 is equal to M1 D1. Substitute M2, nothing is there, M2 times D2 is 8 centimeters equals M1 is that one, 20 grams times D2 is 42 centimeters. Okay, so now we will say, all right, let's say 8 times M2 times 8 centimeters, it will be 8 centimeters M2 equals then 20 times 42, 20 times 42, we will get like 840. So we are getting like 840. So we have centimeters and grams. So here we divide by 8 centimeters, also here by 8 centimeters. So that one goes, will remain with M2 is equal to, so 840 divided by 8, we'll get like 105. So 105, this and that goes, will remain with grams. So say therefore the mass of the row is 105 grams. All right, then they are saying what is the weight of the row. So weight will be is, so I told you that this, if this is a or Roman numeral 1, Roman numeral 2, weight is equal to mass times acceleration due to gravity. Now this mass is there, so we change it into kg. So you say 100 or 105 grams divided by 1000, which will be 0.105 kg. So that is now proper. And then we know that G is 10 meters per second square, so which is also similar to G is equal to 10 Newton per kg. So say equals, now mass, put 0.105 kg times acceleration due to gravity 10 Newton per kg, right? You can see height is just moving. Then you multiply 0.105 times 10, it will be like 1.05. So this and this will go, you remain with Newton. So that will be the weight. Okay, so even here you can say therefore the weight of the row is 1.05 newtons. Just like that, you are done with this question of yours. You can look at another one. This was interesting, this question, the way they brought it. So this question also from Moments, but when someone just look at it, they'll say, this question, what is it all about? So it says figure 4.1 below shows a door well secured on the door frame. So a door is here, well secured, or meaning it is fixed on the door. This is the door frame, this part here. All right. So yeah, that's what it is there. Then they're saying A, what is meant by moment of the force? So the moment of the force, if you want, you can say it is the turning effect of the force. Then they said include its SI unit. So you can say the moment of a force is the turning effect of the force. It is its SI unit is Newton meter. That's the unit they wanted. So you have answered in full. Then let's see the other question. The other question says calculate the moment of force if a force of 10 Newton is applied at point 1 to open or close the door. So you calculate the moment of force if a force of 10 Newton is applied at point 1 to open or close the door. So they are saying you just calculate the moment there. So moment, which is capital M, should be equal to force times the distance between the point of application of the force and the pivot. Okay, so now that is the formula. So they have given you to say, okay, the force is already 10 Newton. So force is 10 Newton. How about this? So you go back to the question. So they're saying calculate the moment of a force of 10 Newton applied at point 1. So go at point 1 on the door and see. So there are 2 points here, point 1, point 2, and point 3. So now they're saying what moment, calculate the moment of the force at point 1 if the force is applied at point 1 here. So you need to know the distance from this point to the pivot. The pivot are the hinges of the door, which causes upon which the door rotates, these ones here. So this is where the moment is. Sorry, this thing I've moved. This is where the moment is. So it's the distance from here to that point. But see here they gave you from here it's just 0.5, then from there again 0.25. So they want you can calculate the total from where the point of application of the force is to where the pivot is. You add these. So it's like you're adding 0.5 and 0.25 so that you get 570 meters. Okay, so that's what you are getting as the distance. So meaning that will be the distance that you are going to use here. So your distance is going to be 0.75 meters. Then your moment now you say force 10 Newton times 0.75 meters, which is going to give you 7.5 Newton then meters as your moment. You see, that will be your correct answer there. Okay, then we move on to see they're saying explain why It is easier to open or close the door if the handle is fixed at point 1 than at point 2 or 3. So they're saying explain why it is easier to open the door when the handle is fixed at point 1 than at point 2 or 3. So let's reason. Science requires us to reason. So equally, you think, why is it easier to open the door when the handle is fixed here than at 2 or 3? Like in reality, have you ever seen a door with a handle just placed close to the hinges here, a handle there? Have you ever seen that? And have you wondered why they don't do that? It is because of moment. So it is easier to open the door or close the door when the handle is placed at point 1, because at point 1 there is more moment than at point 2 and 3. So that's what you can just give them your answers like that. Now you guys reason properly. If you can't reason, you want me to explain again, then it is very, very sad. So you say this is because there is more moment at point 1 than at 2 or 3. That's all. More moment, meaning there's more force, more rotational movement due to increased distance, because moment factors that affect moment are distance. Here from the pivot to here the distance is smaller, just 0.5. Here at 3 there's no even distance. Okay, if I just say, let me prove to you that what we are saying is true, as so that you see that there's reasoning going on. We are not just answering. Moment is rotation. So let's calculate rotation here. If the handle is put here, force, let's say we are applying 10 Newton. So moment is going to be 10 times, what is the distance here from this point to where to the same point? 0. There's no distance there. Moment will be 0 Newton. So there's no rotation, so it can't open. Then at 2, there will be moment is equal to the force same 10 times 2, 0.25, which is equal to 10 times 0.25. It will be 2.5 Newton meters. Here it was Newton, also meter. So this one, it is at least bigger than that, but it can't be bigger than what we found here at 1. At 1 we found the moment that we calculated was a bit bigger. If we check here, okay, if we are to check here, the moment was 7.5. all right, that's why this answer is making sense. This is because there is more moment at point 1 than at point 2 or 3. Okay, then we go to another question here. This question again, someone looks at it will never think it is on moments. So they're saying figure 5.1 below shows a simple bottle opener made by fixing 2 screws into a piece of wood. So there's a simple opener for opening bottles. So they got this wood, then they pressed just a screw, 2 screws according to them. I don't see where the other one is, but I can see the screw here. Maybe the other one is the other opposite. All right, maybe it is there, the other opposite. Okay, so that they can open. This is the bottom, then this part is the bottom top. Then they say, what is meant by a simple machine? Okay, yeah, this one is another topic. So we can say a device by means of which work can be done easily. So a tool that can be used to make work easy, or a device by means of which work can be done easily. That's a simple machine. Okay, I think this one it's a bit like moment and also like simple machine. Yeah. So then they said, which of the points x, y, or z is a pivot, then to effort. So which of the points we have? X, y, z is the F pivot. Pivot is the point where the turning effect is going to occur. Okay, so when you are opening this bottle top, how is the force applied? Do you like push it this way? Because that's what will make us understand. Or you push it down way so that that thing can open. Okay, so for me, from where I stand, I think you can push it. You push it that way using this way so that this thing can push this thing to remove the non-connect, and this thing will be remaining balancing here. But I see two situations where if you push also down here, this thing will balance here. Okay, then this thing will push that one open. Yeah, I see two situations, but the two situations can only be proved in reality if we had the board and we tried to see which one works. But at the moment we can say from where I stand, the pivot should be x. Okay, x is the pivot, and then the effort is where you applied the force from. Z. That's where you applied the force from. Z. Okay, something like that. Then I'm saying, is the force applied at x? Okay, now they have changed the force applied at x. Okay, yeah, there's a force applied at x there. So that's why we are correct a bit there. So they're saying, if the force applied at x is the force applied at x less or greater than the force applied at z. So the force which is applied at z and the one applied at x, which one is greater? The one applied at x. Okay, so we say force applied at x is greater than that applied at z. Again here there's just thinking needed. Again here there's just thinking. Here what is causing this force to produce more moments is the distance from what we are considering as the pivot here to there. There's more distance, therefore the force you apply is less. But from here, from where this force is, that point to where the pivot, the distance is shorter, so the force is more. So there's more force when the distance is shorter. Then they're saying state one modification that could be made on the design of the bottle opener so that less of effort is used to open the bottle. So there again entering into our brain to see if we are reasoning. That's what science is. It enters into the brain of the pupil or learner to see if they are thinking. So they are saying, which design can you do if you're a designer to make sure that you apply less force to open? You make the handle longer. If the handle is longer, the longer the handle, like on moments we are saying, like those guys who unscrews very hard nuts on the trucks or buses, the handle are longer so that you apply less effort. So the design which can be made there, it is to make the handle longer. That is it. Okay, so you can say by making the handle longer. All right, then let's see where we can go now. So let's see if there's another question. More questions, actually, more questions. So this question was like a uniform meter rule is balanced when 100-gram mass on the left side hangs 35 centimeters from the pivot, and a y-gram mass hangs 25 centimeters from the pivot on the right side of the as shown. So we have a y-gram this side and 100-gram here. So they are balancing there. Then they're saying calculate the mass y. As long as they're balanced, use the principle of moment. So this question was a bit friendly because they are all balanced. So you consider this one as, let's say, mass 1. Its distance from here to the pivot is already even given, distance 1, d1. Then this one, you consider this one as mass 2. Its distance already given there, d2. So that's how simple it were, because everything was provided. So say, okay, here we say, using principle of moment, m2 d2 is equal to m1 d1. You substitute m1 is actually y, so they say calculate the mass y. Okay, no problem. So say we'll say m 2 times d2, which is 25 centimeters, is equal to m1 is 100 grams times d1 is 35 centimeters. So you multiply 25 centimeters times m2 to be like 25 centimeters m2 equals, then you multiply 100 grams times 35, it will be 3,500 grams centimeters. Then you divide by 25 centimeters, also this side 25 centimeters. So that one goes, we remain with m2. Then we'll say, okay, 3,500 divided by 25, you are getting like 140. So this and that goes, so you have 140 grams. So therefore y is equal to 140 grams. Okay, so that is it here. I think nothing much to suffer here. So let's move to to the next question. Yeah, another question came in this format where we are told that figure 10.1 shows a uniform meter rule. It is pivoted on the 40 centimeters mark and balanced when an object of 150 newtons hangs on the 20 centimeters mark. Then they're saying calculate the weight W of the meter. So here they even helped to show the weight. So here at the mark is 50. That is the center because we are dealing with a uniform meter rule. Okay. So then here, go now from here to here, it is 20 because 40 minus 20, 20 again here. Then from here to here is 10. You say 50 minus 40, 10. So here it's 10. So weight is not known. So here you say W1, which is weight. This one we can say weight 1. Then that distance there, D1. Then this which is not known, it is weight 2. Its distance there, D2. So then we can say weight 2 times distance 2 is equal to weight 1 times distance 1. Why we are changing? Because we are dealing with weight. So we use weight so that it matches. Then we say, okay, weight 1 is just W. Okay, weight 2 is just W. If we want, we can just put W or leave W2, no problem. Times D2 is 10 there. We said 10 centimeters. Then W1, it's 150 Newton times D1 there, 20 centimeters. Then W times 1 times 10 centimeters, it's like 10 centimeters. W equals 150 times 20. 150 times 20 equals like 3,000 Newton centimeters. So here we'll divide by 10 centimeters, also here by 10 centimeters. So that one goes. So say weight is equal to, this one goes, that one goes. So remain with 1 into 300, 300 the Newton. So that would be the weight. Okay. Then they are saying explain why the meter rule balances horizontally as shown. Because the anticlockwise moment is equal to the anticlockwise moment. So you say because the sum of the anticlockwise moment is equal to the sum of the clockwise moment. So you see, that's how we do the answering. Very, very important. So you need to have these concepts. All right. So let's see if we can still find more questions. All right. We still have questions on moments. So here it was like, what is meant by the moment of the force at a point? What is meant by the moment of a force about a point? So we say it is the turning effect of the force about the point called pivot. Alright, then the same B, moment of a force about a point depends on two factors. What are they? Those factors we talked about: one, size of the applied force, then two, perpendicular distance between point of application of the force of okay, let me just say it: perpendicular distance between point of application of the force and the pivot. Then let's go to figure 3.1. Shows a uniformometer rule pivoted at the 20 centimeters mark and balanced horizontally by an object of weight 3.15 centimeter and Newton placed at the 10 centimeters mark. Okay, so this is the situation. Then they're saying calculate the weight. Again, weight is at the 50 mark. That's where the weight is. Same style, guys, same style. Once you understand these things, same style. So we just need to know the distance from here to there. 10 minus 20 minus 10, 10. Then from there to there, we'll say from here we'll substitute 50 minus 20, 30. So from here to where the weight is, it's 30 centimeters. So if we want, we can just go direct where we say weight times this value here, 30 centimeters. But it's important to quote the principle of moment the way we have been doing. So is equal to, then here say 3.1 Newton times distance 10 centimeters. So here it will be 30 centimeters weight equals this one 3.15 times 10, it will be 30.15 Newton meters. So divide by 30 centimeters, also here 30 centimeters. So that goes, so that we remain with W weight is equal to, say, 30.15 divided by 30, we'll get 1.005 newtons. Okay, done there. Let's see if we have another question. Okay, no questions. I think, yeah, questions come differently, but I think what we have done on moments, we have done enough, at least to open your thinking. as in regarding to how we can answer questions on moments. So for now, ladies and gentlemen, bye and see you in the next lesson.